Since the old days, people used sun and stars for navigation. At first, they navigated only by means of landmarks, mountains, trees, or leaving trails of stones. After a while, people invented technology that helps them to find the way around the world. Maps, compasses, astrolabes, and calipers are among the early tools used by navigators. But today, more accurate satellite navigational systems are available. GPS, or the Global Positioning System, is such system invented by the U.S. Department of Defense, in collaboration with the Massachusetts Institute of Technology. It is a satellite navigational system, predominantly designed for navigation. Originally consisting of 11 orbiting satellites, the GPS official name Navstar was launched by Department of Defense in 1978, strictly for military use. Initially developed for the military, GPS was made available for public use in 1983. The Korean airline Flight 007 tragedy, in which Soviet fighters shot down a Korean civilian aircraft lost over Soviet territory, led to the removal of security classifications by then United States President Ronald Reagan, and allowed Global Positioning System to be used by civilians. In 1990, the GPS facility for public use was temporarily suspended, as the military needed more receivers to enhance its use for military purposes, in the ongoing Gulf War. It was made available for public use in 1993. Simultaneously, it was decided to provide this facility free of cost, all over the world. By 1995, Global Positioning System had become a considerably advanced navigation system. It had achieved full operational capacity, and the number of satellites had also increased, thereby increasing the availability and accuracy of the technology. Since 1995, GPS history has seen considerable technological advancement. More satellites had been put into orbit, increasing both availability and accuracy. Previously, GPS could locate a subject within 100 meters. That accuracy improved to finding subjects within 10 to 15 meters, and, at present, can be measured within centimeters in some cases. The GPS system was developed to meet military needs. But new ways to use its capabilities in everyday life are continually being found. Today, GPS is used in aircrafts, ships, cars, construction equipment and many other applications. GPS consists of three main segments: space segment, control segment and user segment. This part consists of 24 satellites, manufactured by Rockwell International, which are launched into space by rockets, from Cape Canaveral, Florida. Each of these 3,000 to 4,000-pound solar-powered satellites circles the globe at about 12,000 miles, making 2 complete rotations every day. There are 6 orbital planes, each having 4 satellites. The orbits are tilted to the equator of the Earth by 55 degrees so that at any time, anywhere on Earth, there are at least 4 satellites visible in the sky. The satellites continuously orient themselves to ensure that their solar panels stay pointed towards the Sun, and their antennas point toward the Earth. Each satellite carries 4 atomic clocks. Control segment consists of 5 worldwide unmanned base stations that monitor the satellites to track their exact position in space, and to make sure that they are operating correctly. The stations constantly monitor the orbits of the satellites and use very precise radar to check altitude, position and speed. Transmitted to the satellites are ephemeris constants and clock adjustments. The satellites in turn use these updates in the signals that they send to GPS receivers. The user segment consists of user receivers which are handheld or can be placed in a vehicle. All GPS receivers have an almanac programmed into their computer, which tells them where each satellite is at any given moment. The GPS receivers detect, decode and process the signals received from the satellites. The receiver is usually used in conjunction with computer software to output the information to the user in the form of a map. As the user does not have to communicate with the satellite, there can be unlimited users at one time. A GPS receiver's job is to locate 4 or more of these satellites, figure out the distance to each, and use this information to deduce its own location. This operation is based on a simple mathematical principle called trilateration. Knowing distance from one satellite places you somewhere on a spherical surface that's centered around the satellite. Knowing distances from 2 satellites places you somewhere along a circle that's between the 2 satellites. Distances from 3 satellites usually intersect at 2 points. The Earth itself can act as a 4th sphere. Only one of the 2 possible points will actually be on the surface of the planet, so you can eliminate the one in space. Receivers generally look to 4 or more satellites, however, to improve accuracy and provide precise altitude information. There are 3 basic functions of GPS. Give a location, point-to-point navigation, and keep a track. A GPS unit accurately triangulates your position by receiving data transmissions from multiple orbiting satellites. Your location is given in coordinates, latitude and longitude, or universal transverse Mercator. If you have the coordinates for the destination you're headed for, a GPS can give you a straight line, point-to-point bearing and distance to your destination. Since trails rarely follow a straight line, the GPS bearing will change as you go. The indicated distance to travel will also decrease as you approach your goal. One of the most useful functions of a GPS unit is its ability to lay a virtual breadcrumb trail of where you've been, called a track. You can configure a GPS to automatically drop track points over intervals of either time or distance. To retrace your steps, simply follow the GPS bearings back through the sequence of track points. Before taking a GPS measurement, stand where you have a clear view of the sky. Buildings, hills and trees will block the signals from the GPS satellites. The goal is to receive a signal from as many GPS satellites as possible. To provide reliable navigational information, including your position, a GPS receiver needs to receive good signals from at least 4 satellites. To acquire satellites, turn on your GPS and go to the satellite screen. This will display the current configuration of the satellites and the strength of the signals. It may take several minutes for the GPS unit to lock into the satellites, so be patient. The satellite page provides a picture of satellite signal tracking, tells you when the unit is ready for navigation, and shows your location coordinates. Sky View graphic represents a view looking up at the sky from your current location, showing satellites and their assigned numbers. The outer ring represents the horizon around you. The inner ring represents a view above you at a 45 degrees angle from vertical. And the center represents directly overhead. Signal strength bars for each satellite are shown just below the sky view. Satellites and their signals appear as hollow shapes until a signal is received, and then they appear darkened in. The stronger the signal, the taller the signal bar. To simplify map navigation, a system of coordinates is used. Coordinates divide the map into a grid and identify a particular location by listing its relative position north, south and east-west. To choose a coordinate system, simply go to the Preferences screen. The most common coordinate systems used in GPS navigation are degrees, decimal degrees and universal transverse Mercator. To save the current position as a named or numbered waypoint, you must access the function for your unit that does this. On many of the Garmin units, the Mark button is specifically for this purpose. The naming process is usually simple, using the up and down arrows of your keypad to choose various letters and the left and right arrows being used to move to the different characters. With waypoints in place, your GPS receiver can guide you from point to point. Use the Find or Go To button to identify a particular waypoint target. Then switch to the compass screen, where the GPS receiver will give you a bearing and estimate the distance and time of travel. When you enable the track recording feature, the GPS unit will automatically set track points as you go, essentially laying a breadcrumb trail to show where you've been. You can adjust track points to be laid at specified intervals of time or distance. The shorter the distance between track points, the more accurate the path back. The intervals you select should depend on the presence of a marked trail, the terrain, the weather and other conditions that you find. In addition to this essential guiding feature, tracking also allows you to record time and distance traveled. Later, you can download recorded waypoints and tracks to your computer. GPS camera can be used to take geotag photographs in which geographic coordinates are saved. Generally, GPS camera comes with an inbuilt GPS receiver. In case it does not have an inbuilt GPS, you can use it with any other GPS receiver supported by the camera, such as a Bluetooth GPS receiver. After taking the photo, you can view it using Google Earth or similar softwares. If you have a compatible GPS device, recent versions of Google Earth Plus and Pro allow you to track your movements as they occur. For example, you could track your travel progress in a plane or in a car with a GPS device connected to portable computer with Google Earth. Of course, imagery in Google Earth depends on an internet connection. As a workaround, you can cache your imagery of your route before departing. The future of GPS is as unlimited as our imagination. New applications will continue to be created as technology evolves. GPS satellites, like stars in the sky, will be guiding us well into the 21st century.